this Bentley Continental GT was on fire. And somehow the only thing that it got destroyed is those vacuum lines. And that's the worst possible system that actually could get burned, because I need to remove the engine. So instead of taking the engine out like a Bentley said, I'm actually gonna build the entire new vacuum system from this copper pipe. So in the last video, there was a huge flame in this section in here, and probably that was actually kind of my fault, because I was bleeding the brakes and some of the .4 actually went on a catalytic converters and it set on fire and then burned one of the vacuum lines, and the other vacuum line was actually cracked, and it didn't get melted, but it was cracked, so it was leaking anyway from that side. For the Bentley Continental GT, if you know, the vacuum lines are actually very important. How I'm gonna build the vacuum lines without knowing where they actually route? Let me think. I might actually got a solution for that. But, original vacuum lines for the Bentley Continental GT, and they go underneath the steering rack. And if I want to replace them, I need to remove the engine, repair the vacuum lines, and install the engine again. But you know me, I'm not gonna do that. The car doesn't overheat, it actually drives, there's no leaks, there's no coolant leaks, everything is perfect. And I'm really not willing to bleed the entire system again, so I could repair those. So like I said, what I'm gonna be doing, gonna copy those lines and use this copper pipe. So basically, we should be bulletproof after the repair is done. So what actually happened? Well, it's a bit crazy story, because I was bleeding the brakes, and while I was bleeding the brakes in the back, one of the bleeder hose split and it went straight onto the catalytic converter. And obviously you know what's happened next. The catalytic converter get hot, the brake fluid set on fire, it melted one line, another line for the evap system was cracked before, so we're not losing anything. But the most important is that the flames was literally over there. So all the wiring, turbos and engine survived this fight. The car still starts, it still runs, and it still drives. So that's a very good point that I actually managed to put down that flame in time. But one of the vacuum lines, they haven't survived. And that specific pipe is actually here. Is this one? Yes, that's the one. So this is the pipe that is actually melted somewhere in this section over here. So the factory repair procedure would be front end out, all the coolant out. Then I would need to drop the engine down. And if you know me, this is a 5x5 garage. I do not have a lift for this kind of procedure. So no, this is not gonna happen. I'm gonna rebuild the entire system from the copper pipe. I got OEM vacuum system, so I got a nice example how the vacuum system is actually done. So I'm just gonna follow all this procedure, how they done it in a factory. Just everything is gonna be visible in the engine bay, and if I will need to maintain in the future, I can actually do it myself easily without removing the engine. I've seen on YouTube there's a lot of people actually upgrading the vacuum lines, but the problem is all of them are taking the engine out, and it got me thinking, why not just like run the vacuum lines somewhere in the top nicely? I mean, it's only two pipes each side that actually connects to everything. So let's say, for example, this pipe, it goes to the turbos, this one goes into the evap system, this pipe is a main feed, which goes to the vacuum pump. This pipe from here, it actually goes from the other side of turbo, and those two into the intake manifold, and the last one goes in solenoids. So that's kind of easy. The only thing why I bought this, because I wasn't too sure where is the return pipes for those, because you know it actually has one-way route and it needs to follow the exactly same route. So basically what I'm gonna be doing, I'm gonna leave this aluminum pipe in here, and all the rest of plastic pipes, they're gonna disappear. And I'm gonna try to make everything a bit smaller, tidier, and run somewhere here nicely in the engine bay. So I'm planning to actually try to get it in this section in here, so I could actually see the pipes all the time, and if I need to maintain them, that would be very easy and simple. So why I'm using a copper pipe instead of other rubber hose? Well, basically, copper pipe doesn't melt, it doesn't crack, you can easily bend it, and it's actually gonna look much nicer than just a normal rubber hose. And the best thing, it won't collapse under the vacuum, and it also heat resistant. And if you know my luck, this car had been on fire like 3 times already in the same place. Why, I don't know, but that's my luck. With this, there is a risk. If I'm gonna get this routed wrongly, I might get overboost or underboost. But at this point, I have absolutely nothing to lose. And if I'm gonna succeed in this, a lot of people who has a Bentley is gonna thank me for explaining and showing how the vacuum system is actually built and how you can avoid your 4,000 pound bill. So the way I'm actually thinking to do now everything, I'm gonna remove all the plastic hoses and just connect the copper ones, because I got few bolts that I can use and actually tighten up the new vacuum lines. And I also got quite accessible holes to reach the turbos and the evap. So now I just need to have an access to a brake boost hose, and then we can route all the rest of the hoses into wheel arches and then just plug it in into the existing vacuum lines and hope for the best that it's actually gonna work. On a Bentley Continental GT, the brake booster vacuum system is one of those simple things buried in a non-simple places. To access it, you need to remove the window wipers and that huge plastic cover. Alright, so what I have just found, that my brake vacuum pipe is actually going in here, in this direction over here, and it looks exactly the same as this. So basically what I'm gonna be doing now, I'm just gonna cut it off from the car, and then I'm gonna plug it in onto this one, and then I'm gonna start upgrading with the copper lines, so we would have a bulletproof and fireproof lines. Now here's something most people don't talk about: vacuum lines. On a 2005 GT, vacuum runs a lot more than you expect. We're talking turbo actuators, diverted valves, secondary air system, engine mounts, even parts of the HVC system, and when one tiny line cracks, boom, boost leaks, rough idle, random fault codes, or turbos not hitting full pressure. The problem is heat. The twin turbo VW cooks everything. After 15-20 years, those rubber lines got brittle, split underneath the intake, and you won't even see it without digging in. So if you got hesitation, limp mode, or inconsistent boost, don't just blame the turbos. Check the vacuum network first. Is cheap hose hiding in a very expensive place? Classic Bentley. So this bottom hose, which used to look like this, is responsible for your evap system and vacuum pump. So basically one side of here has to go all the way to this side into the evap system. So if I can connect this one to the evap, that means that we have one line connected. Then we need to get the copper pipe going from this hose, or actually going into that hose in here. It's this one, right in here. So I need to put now a copper pipe up to the purge tank or vacuum tank, whatever you wanted to call it, that's how it's called. But this is the main feed where the vacuum is actually appears. So I need to get that pipe in here somehow, through somewhere. I need to find a hole in this mess, and then I can connect main line of this. Then afterwards I need again 2 more vacuum pipes. One is gonna be going from left side from the turbos and another one from the right side. Sorry for taking a break by saying something, because I really need to calculate and think what I'm plugging in, because one small mistake and the car is gonna overboost or is gonna be underboost. So I need to think before I'm putting everything in. That's why now I'm just putting everything on a top position here, so I could plug in later on the smoke test and check if everything is actually plugged in correctly and if I do not have any more leaks anywhere. And afterwards, after that's gonna be done, I'm gonna run 2 more pipes from here to the intake manifold. So that's gonna be in the both sides. And then this pipe is gonna connect to the brake booster over here. And if it's actually gonna work, then I can tidy up everything how it's supposed to be, well, how I want to be, and this is gonna be pretty much it. Right, I'm not too sure if you can actually see something, but that's how my evap looks. It's all melted off, so there is a rubber piece in here, so I need to get this pipe into this rubber piece. So this copper in here as tight as possible to the corner, because I don't want that the steering rack would actually touch it. So I just need to remove this hose clamp, push this one like this, for example, and bend it that way so it wouldn't touch all the rest of the system. So it literally has to be somewhere about here, like this, and then that can connect into that. So that's my evap. Okay, that side is sorted, kinda. I still need to, like I said, plug it in the turbo pipes, but I need to do more important stuff. That's gonna be other side, the main feed. So I need to get the copper pipe into this location so I need to get the copper pipe into this location as well, and then I can plug it in all the rest. From the factory, the brake booster pulls vacuum off the intake with a big molded line and check valves. Works fine until boost, heat, and 20 years of brittle plastic says otherwise. So relocating the vacuum source up to the top is a smart move, especially if you're doing this with a copper pipe. At this point I'm installing all the copper wire in a visible position, and then I will be able to see if I got any vacuum leaks in the future. And also it's gonna be very accessible, and I think it's gonna be heat proof. So I got my feed and the evap system now connected to one pipe. Now what I need to do is connect to the intake manifold and to the turbos, and then we can finally test it and see if it's gonna work. If it's gonna work, I'm gonna be so happy, because I won't need to remove this engine for the 3rd time. And if you're wondering where I actually found the place to put a second pipe, well, from nowhere there was a hole, just appeared from nowhere. I mean, can you believe that the Bentley made a hole in this place just to fix their vacuum leaks? I mean, this is a mind-blowing, isn't it? I know I just drilled a hole in a Bentley. Don't get mad at me. For the turbo pipes, I actually got an idea. Instead of plumbing those through the arch lining and doing all other stuff, there is a pipe that it goes directly from turbo to the vacuum lines. So if I would unplug this and would plug another pipe into here, that will work, theoretically. Same with this side as well. There is a vacuum pipe in there, but it's a different story, because it's not in the correct position where it's supposed to be. To access it, well, let's say you have to have a child's hands, because it's somewhere over there. The only important thing is, do not connect copper directly to the brake booster or the pump. You always finish with short section of reinforced rubber or a silicone vacuum hose, proper barbed fittings, a one-way check valve close to the booster, but already using half of the original piping, so the brake booster is still fitted in the place. Why? Because engine moves, copper doesn't. If you hard mount copper at the end, vibration will crack fittings or the boost nipples, and that becomes a very bad day when you hit the brakes. Now, before everyone panics, this is a pure test setup. I'm mounting it on the top of the engine so I can actually see what's going on. I just want to know one thing: will it work? So instead of guessing, instead of throwing parts at it, I'm fabricated a solid copper line that won't collapse under the vacuum and won't split under the heat. And I can't lie, it looks completely out of place. You open the bonnet of the Bentley and you expect quality and refitment. not plumbing supplies. But if this works, it proves the issue isn't elsewhere, it proves the system can hold vacuum, and it gives us proper direction to go on. Everything connected, hose clamped, no obvious leaks. This is the moment of truth. Will this 10-pound copper setup behave better than original Bentley design? So theoretically everything should work how it's supposed to be, without any leaks or something. The only thing that I still need to connect is the brakes and into the brake booster, which is not gonna be that difficult, I'm assuming. And afterwards, if that's gonna work, I'm gonna order it the correct size of the pipes, what I need for the turbos, so I can run them nicely, and then figure out how to tidy up everything around in the engine bay, so it would be visible but not noticeable, if you know what I mean. This one is gonna be the last to actually test this Frankenstein. Have you ever seen somebody doing this to the Bentley? I'm just thinking, should I just start the car and see if it's gonna work, or should I just plug it in the smoke testing tool and check it if there's any vacuum leaks anywhere? Let me think. I think we're just gonna start it and see what's the worst could happen. This time, if the car gonna set on fire, I'm actually gonna record. So, let's start it. Well, it definitely sounds much better than it was before. 100%. I can still hear a vacuum leak somewhere, probably because I didn't put any clamps on it. But the evap is connected. All of these are connected. I definitely can hear that vacuum leak. But where it is, only the smoke test machine is gonna actually show. Just to double check, is there any fire? Nope, there is no fire, so that's a good sign. I still got somewhere a vacuum leak, I can hear it. Even though the car actually sounds good now, I still got almost exactly the same faults. Few or less. So I'm actually, to be honest, not even too sure what's going on now, because all the vacuum system is now kind of completed. I still need to put all the clamps and put it back in the places where it's supposed to be, but I think it's gonna be something to do with this evap system purge canister. That's the only thing I can figure out. I think it's not even working. Let's plug in the smoke test machine and check. Right, moment of truth. Time to test new vacuum setup with a smoke machine. Now, the idea here is simple. Pressurizing the system with the smoke and see if it holds. If there's a leak, we'll see it instantly. So I hook everything up, turn the smoke machine on, and it starts smoking like an absolutely chimney. At first I'm thinking, oh no, what I have done. But then I realized I didn't install any hose clamps. Brilliant. So obviously the smoke is pouring out of every connection like it's been launched a steam engine under the bonnet of the Bentley. Right, let's do it properly. I start installing clamps on all of the connections, tightening everything down so the system actually sealed, one by one, locking in all places. Okay, round 2, smoke machine back on. Now it's holding way better, but then I noticed something. There's still smoke coming from elsewhere, and the worst part, it's leaking from the area I haven't even touched. That's when you realize the copper pipe wasn't the problem at all. Somewhere else is very complicated, very expensive vacuum system, there's another weak point. So obviously bumper off, headlight out, and inspect where it's actually started to leak. Because at this point I think that I connect everything correctly. I think I found most of the problems, because this intercooler pipe is not even on. So that's the one thing to fix now. We've been running the vacuum test for at least a half an hour. Not a single smoke came out. The only thing, it didn't build up the pressure. So I'm not really sure where that vacuum is disappearing, but I plugged in back the intercooler hose. So let's check if that's gonna change anything. Now I can hear the 2 cylinders are not working, but the gas pedal is definitely more quicker response. So if I would try to read the codes now again and delete them, it might actually change something. I really would like to fix this car, but it's keep fighting with me. Air suspension, by the way, is now deactivated, so it's not gonna start raising up and down just without any reason. But that engine light is actually annoying me quite a lot. Right, trouble cores are not detected, so that's good. That's a control module 2. What about control module 1? There's 12 volts on that. Quick erase. Please, 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 please let it work, let it work. Obviously I'm gonna start the car and then gonna be a lot of volts again. Okay, let's try to start it again and check. Oh, the brake pedal is so hard. No engine management light yet. Not yet. No way, please. There's... and it's on. Come on. That's literally how I feel now. Dear God, please help me. I have no idea what's going on. Well, I kinda know what's going on, but I really hope it's not gonna be that case. I think it's gonna be some damaged wiring somewhere, and that's not a good thing, because if I want to repair all the wiring, I need to inspect them, and to inspect them I need to remove the engine anyway. I really hope it's not that case. I really do. Also, we got few new names on YouTube community posts. So we got Raymond D and Darren Wall. Thanks guys for joining the community post, and thank you for supporting my channel. So if you want to be on this YouTube community post, I'm gonna leave the link in the description for my PayPal details. It costs only £1 to be on this post, and I'm gonna shout out your name while I'm filming. And also, I still got some nice air fresheners for sale, so don't waste your time. Grab a couple of air fresheners, and that way you're gonna support my channel, and also you're gonna have the air freshener from me. What I need to do now is remove the intake manifold, but you've seen me removing the intake manifold for many times, so just... And the intake manifold is now out. And also we got a Jesus Pawel, because he's actually a god, or Jesus, or whatever you want to call it, with all the electrical work. He's gonna check what's going on with all of the injectors, and, well, not all, cylinder 10 and cylinder 3. What are you now doing?
Checking if that, have you got, checking how that flow will work, like this. Cool. Right, so, let's go with the non-good one, which is not 12 default, and check if it's got like a constant ground or constant response, like 300 ohms to...
Should I turn on the ignition?
Ideally, you could crank it, but just briefly, like very briefly.
Okay, the whole business. I mean, it's like, okay.
So now the advantage of an old school probe would...
Like you could send the power?
Not really, I could like see the light flashing, you know?
Oh. You said old school probe.
Yeah, like the one I've got in my bag. Yeah.
Oh, no, I don't have that one.
Yeah. Go on.
Slightly, yeah?
Briefly, I put like a second, yeah, or 2 seconds. Right, so it's bit of a clear. Okay, cool. Now let's unplug the
So you just like push it, like, yeah, I got another 12 of them, so it's not an issue. Yeah, it should. It should make a click.
Pushes, yeah? That pushes in.
And then makes the click. 1, 2, 3. This one's even. Yeah, this one is holding. So the resistance matches on the cylinder 7 and cylinder 10.
Yes, both of the injectors have the same resistance. Obviously, we've checked the cylinder 7. As we know, the cylinder 7 is working, not showing any faults, and it's showing like roughly around 12 ohms. Let's double check that again. So here we go. Let's untangle the wires. So we're measuring the resistance of a 11. It was 12. Yeah, 11, 12 ohms. And
You need some light, yeah?
Yes, please. Don't laugh at me being blind, yeah?
He's old.
Same. It fluctuates a bit, but then there's a question whether I'm holding it nice and tight. Yeah, it's 12 ohms. When I press it nice and firmly, as much as I can. Yeah, 11, 12 ohms of the second resistor. Let's inspect this plug here. Plugs looks absolutely beautiful. Is the ignition on?
No, I can turn it on now.
Yeah, please turn it on.
Ignition on.
Ignition on. So we go to the multimeter function. The battery voltage is too low. Please start the. Oh.
I don't need it. It's I can plug in the charger if we need it.
Yeah, please plug in the charger.
Charger plugged.
Charger plugged. Let's check if we got like okay 0, and that we should show like where's the 11.4. Yeah, okay, that's enough for testing purposes. So we should have 11 or something on one of the We've got battery voltage on one of the connectors, and we've got about 3 volts on the other connectors when it's not idling. It's quite odd, but on all the other injectors is the same, so I'm assuming it's not the issue of the
wiring.
About the wiring. My point is now to wiggle the wires, wiggle, to see if anything is going to change. Could you wiggle the wires next to the ECU maybe?
Worse.
Huh? Wiggle, no wiggle. What?
That's just this pump.
Okay. Yeah, no wiggle, nothing changes. Yeah, 2.9 something. Okay, let's see the other contact. It should be 11 point something. The battery.
What the hell?
You need some coolant in this vehicle, boy.
There is.
That means the electric pump might be dying.
Could be.
Like we don't have enough volts, yeah?
Yeah, exactly. Nothing.
Huh. Right. So that leaves us with wet ECU.
Yeah.
Probably, maybe.
There's a chance that the ECU is actually now bad.
Right. Let's plug in the diagnostics. Plug in the what's the space? The
Live data or something.
plug in the
Intake.
injectors. Come on.
Ah.
So what we can do now is try to do active tests on the injectors, like some of them working ones. Active test, which means connecting the diagnostic device to the vehicle and go into active tests, and you can actually actuate whatever you want to actuate, such as...
That's how I actually found that the wiring is mixed up. I don't know why I haven't checked it this yet.
Right, but that was a long time ago, yeah?
That was a long time ago. That one.
We can check the injectors one by one, see if it actually fires up. If
That was a time.
It still shows the fault. Then
ECU?
it looks like ECU, yeah.
Damn it. So all the injectors are actually working.
All of them are clicking.
What about
So that means
3?
What, 3? Injector 3.
Yeah,
That's
injector
the
3.
ECU number 1. I'm plugging into ECU
okay.
number 2 now. But yeah, on this bank, we've checked all the cylinders and all the cylinder injectors, and the injectors are actually clicking, like click, 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 click. Which means they are getting controlled by the ECU, they are getting powered, and they do something, and they do have a correct resistance. So,
So what's going on?
interesting why there's a fault. Yeah.
You know what was all the time?
You know what? I don't like getting filmed when I don't know what's wrong.
Okay, right, so what we just found it out, that EVAP, I'm not to show you how it's even called.
EVAP canister pure solenoid valve, which is this thing over there.
So it's dead.
Yeah, it's dead. It's got 23 ohms. However, when we apply voltage to it, it does absolutely nothing except like a tiny little spark when touching the
So
connector.
it's shortened and this.
No, it's probably jammed inside or something like that, because it should be clicking, yeah? It should, when that gets the voltage, it should click. Like normal solenoids, you probably like tested hundreds of them. And yeah, they do click when applied voltage. So it opens and closes, and when it opens and closes, you should feel tiny little clicking inside.
And the noise should be like click, 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 click.
Yeah, exactly, clicking. So this one,
Dead.
no click.
No click. Alright, at least we found one thing of the
like
million,
300
yeah.
million, but yeah, we'll get there at some point. Maybe in this century.
This century. Yeah, I'm planning to drive this car in like 2030.
Retirement plan.
Yeah, retirement plan. So this is gonna be.
By then, that's gonna be a proper classic.
Oh yeah, definitely. And probably all the cars is gonna be electric, and nobody gonna start selling the petrol. So it's just
So we're gonna have to brew our own, boy. You know, old school moonshine.
moonshine. And then there's
Moonshine powered Bentley.
then there's gonna be a YouTube title: Moonshine Powered Bentley.
That's a good one, yeah.
Right.
Yeah, so that'll be it for me for today. I'm gonna leave you guys with him.
That's gonna be it for me today as well.
Okay.
Because I need to go as well. It's
So let's go
Valentine's.
home.
It's Valentine's Day. Yes, tomorrow the video is supposed to be released.
I should probably not hug him now, you know? Like, you know, Valentine's Day.
Yeah, that would be a bit awkward.
Yeah, it would, so let's not do this. Yeah.
Thank you so much for watching this video. If you enjoyed it, click that subscribe. If you didn't enjoy it, don't click that subscribe. But it would be great if you would click a subscribe. I will see you in the next video.